Okay, as you know, the last couple of years that you've been here, we have definitely been talking about the Open Process Automation Forum, about the fact that their open process automation is coming. EOSYS has got a couple of people that are engaged with that. Our Director of Technology, Chase Davis. Last year we had, I think, Dave DeBari with Exxon talking about their Lighthouse project that they were working on and going to get going. And they have since made some progress on that. And today I'm very fortunate. We have a speaker with us today, Don Bartusiak, and I'm going to read a little of his bio. He's the founder and president of Collaborative System Integration, the co-chair of the Open Process Automation Forum. He is the retired chief engineer process control for ExxonMobil Research and Engineering. He was with them for 33 years. He was a research engineer for Bethlehem Steel. Don is a ISA Excellence in Leadership Award winner. He is an IFAC fellow. He's an American Control Council Engineering Practice Award winner. Basically, if anybody can say they're the father of the open process system, I think Don has as much claim to that as anybody does. It is an honor to have him with us, and I really appreciate the fact that he came for this. So please welcome Don Bartusiak, and we'll get an open process update.
Okay. So it was yesterday afternoon during the session you guys had for feedback. Dave's like in the back behind me jabbing me. He said, Don, tell him about the future. Tell him about the future. And I didn't want to spoil the fun you were having yesterday, giving feedback to Schneider. Okay, so okay, what I'm going to talk about, I'm going to talk about the problem that we're trying to solve. Dave's already given a good introduction to open process automation. But I do want to tell you a little bit about the story and the foundations first. But most of my time and remarks will be on this topic about industry adoption. What are the operating companies doing now in terms of putting open process automation standards-based systems into production service? So that's really what I want to, the message I want to impart today. So what's the problem that we're trying to solve? What motivated all this in the very, very beginning? So back in 2009, ExxonMobil was faced with the proposition of having to replace basically all of their control systems in the refining and the chemicals business with an estimated price tag in around $5 billion. And it was basically it was a non-return project, right? You put a new control system in, but you wouldn't be able to do much more than what your current system was doing. So that was a big problem for management. And that induced the start of a research project to really fundamentally solve that business problem. And so what was the problem? It's the high cost non-return proposition for control system upgrades and replacements. So we studied that problem for about a year. We spent another year talking to all the major DCS vendors. And we realized it didn't matter which supplier you used. The fundamental problem remained. And so what were the root causes of the problem? Well, the root causes of the problem were the lack of interoperability among products from different vendors, the inability to reuse software applications across vendor platforms and often between generations of vendor products. Upgrades were expensive because of the proprietary connections between the components of a system, a lack of modularity. And there were the barriers to value generation from the closed proprietary nature of the currently available control systems. I mean, I used to make the remark that essentially the vast majority of business value that we created with control over the past 20-ish years came from systems that we deployed at Purdue Level 3, had nothing to do with the DCS itself, okay? And finally, this was just a comment, and it's not really a critique of the DCS vendors, it's just the systems were designed in a day and age when we didn't really worry about cybersecurity. So what you had to do for cybersecurity protection was basically just bolt on defensive things around the perimeter. So these were the pain points that motivated the problem we were trying to solve. So again, after studying the problem, thinking deeply about it, writing some reports, circulating them around the industry, we came up with a vision for the solution to the problem. And the vision for the solution was to move away from closed proprietary systems to standards-based, open, secure, and interoperable architecture for process automation, which we eventually named Open Process Automation. So how did we get there, and how did we come up with that vision for the solution? It was the outside the box part of our thought process during those years was looking at how other industries that had similar problems solved it. And we were inspired by what we saw in the avionics industry, the electronic systems on aircraft. We were inspired by what we saw in networking, which, if you remember back in the day and age when before smartphones and the internet, how did the telecom companies support the massive increase in data traffic once smartphones got out there? They basically transformed the networking industry. And so those inspirations led to what we call, this is our vision for the solution, and this is the Open Process Automation Reference Architecture. So it's not the Purdue model. It's not hardware defined. It looks IT-like, but it's not a flat network, okay? You can still segment. You can implement zones and conduits in IEC 62443 speak. It moves from a hardware-defined nature to a software-defined nature. So all of these are the kind of the attributes of the system that we envisioned. Industry standards for interfaces and networks, interoperable hardware and software, open software access in terms of the ability to introduce third-party software products, and designed in cybersecurity. So how do we achieve that vision? Well, fundamentally, it comes down to having an industry standard, that the first part of that vision phrase, the standards basis, okay? So this is what the Open Process Automation Forum of the Open Group is all about. And it's more than just creating the technical specification. The way that the Open Group works, the Open Group's chops, they're the keeper of the Unix standard. That's really their claim to fame. They've been in business for about 35 years. But what's different about the way that they approach industry standards is not only to work the technical spec, they also address the creation of the business ecosystem required for the transformation, and they also try to bring in phase a conformance certification process so that the buy side of the market can buy with confidence. So right now, the OPA Forum, which Dave mentioned in his opening remarks, has about 100 member companies, 19 operating companies, 6 of the 7 global DCS companies, a plethora of hardware and software suppliers, systems integrators like EOSYS, a couple of universities, etc. So you can see the splash of companies there. Many of your companies are already members of the forum. So that's the who. The what, so here's a summary of the OPAS standard. It's being released in part documents. There's now, at present, there's over 1,000 pages of documentation that's been published in the specification. I'm going to be somewhat brief in my comments on what the standard is. So it maps, we call it a standard of standards. So it references other standards. We want to avoid reinventing the wheel. So let's just call out some of the particular referenced standards. So ISA 95 is fundamental to the architecture. ISA 99, aka IEC 62443, is essential for cybersecurity. Connectivity framework depends a lot on OPC-UA, and the standard Ethernet networking profiles in IEEE 802.3. There are some new technologies to the OT domain coming from IT for systems management. There's a software and a data model called Redfish, which is from the Distributed Management Task Force. Part 6 is largely about the information models that are necessary to achieve interoperability among software products. There's a specification for the physical platform, which is about the connectors, basically down at the I/O level, and also it will emerge eventually with a specification for a backplane. And so through Part 7 is what's been published to date with OPAS Part 2.1. Okay, so we're now like 6 years into this enterprise. And OPAS, basically what the suppliers are telling us is that OPAS version 2.1 is defined enough to begin to enable the suppliers to create products against. So that's where we are in the marketplace right now. The new territory, what will come out in the next release of the standard, is Part 8, which is about software portability, which will call a lot on virtualization and containment technologies. And also what's called system orchestration, which is another technology that's coming in from IT and telecom service that's going to give us great strides forward in how we automate the management of industrial control systems. So that's what you're going to see in terms of coming attractions. I talked about the business ecosystem at the beginning. So from an operating company's perspective, you need to think about what's depicted on this chart. So those colored boxes are roles. A company can play one or more roles in that ecosystem. So the operating company, your single point of contact for a project would be the role of the systems integrator, that green box, and EOSYS is an example of that. Then you'll have, beneath the systems integrator, there will be supporting functions. We call them subsystems integrators. My company and a partner company called Seaplane are examples of that. We provide the deep technical expertise in the standards and in the technology. And then you work with hardware and software component suppliers. Okay, so that's a contrast to the one-stop shop of today's DCS vendors. Okay, this is the ecosystem that's going to emerge for the realization of the open process automation vision. Okay, so let me just keep moving forward. Listen, guys, I would be happy to answer questions in real time if you just want to call out. We're going to time budget a Q&A later, but if you have a burning question, you can call it out. I'll spend just a minute on this chart here. I mentioned conformance certification, so we have started up the conformance certification process. This list of what we call profiles and facets is what is now operational for Wave 1A. So it has to do with basically the hardware requirement for the distributed control node DCN, some specifications regarding Ethernet networking and time synchronization. OPC-UA pub sub is available for conformance certification testing. Not just plain vanilla OPC-UA, has to do with the information models as well as I talked about earlier. Cybersecurity testing with against 62443, and also that Redfish systems management capability. So suppliers can now submit products for verification that they conform to the OPAS standard. And like what you can see out in the exhibit area from my shop and also from Phoenix Contact are examples of products that are highly likely to be conformance certified shortly. Okay. Now let me shift gears here a little bit, and I said that's the story, that's the foundations of the industry standard, the business ecosystem, and conformance certification. Now let's talk about moving into commercial practice and production service. So I'm going to talk about test beds and pilot projects that have been done by the operating companies, and also systems that are moving into production service. So this is a table that I use to tell the story in a nutshell about the operating company prototyping projects. So in effect, there's a chronological order going down column 1 about who started when. And the columns in this table basically represent degrees of sophistication or maturity, starting from a test bed, which basically you're just evaluating products, getting your feet wet. Prototype probably performs some type of control function. And finally, I'll talk about the ExxonMobil field trial that Dave mentioned in his opening remarks. And I'm going to, yeah. I think you have folk from Dow here. Yeah, so I actually cherry-picked my slide set to provide specific examples of these projects, okay, for this audience. Okay, so let me introduce the ExxonMobil activity first. So what Dave mentioned in his opening remarks, the Lighthouse project, aka the field trial. So this is ExxonMobil's third OPA system build. If you remember what I said in telling the story, we used avionics as a role model for what we're trying to accomplish with open process automation. And Lockheed Martin was the company that really Lockheed Martin and Intel really opened our eyes into the art of the possible. So the first couple, the proof of concept, the first build, the prototype of ExxonMobil, the second build, were basically done by Lockheed Martin. Anyway, the schematic on this figure is meant to depict the component products that were looked at for ExxonMobil's field trial project, aka Lighthouse. The system was staged in ExxonMobil's headquarters facility in Spring, Texas. Yokogawa and Wood were the two systems integrators on that job. But the Lighthouse project is actually running a resin manufacturing facility in Baton Rouge, Louisiana. It replaced a TDC 2000 system, several PLCs, there's one operator post, about 1,000 I/O with about 100 control loops. And it was commissioned successfully in November of last year. And it was reported on at this year's ARC Forum meeting, which was last week in Orlando, Florida. And the hyperlink I've given you here is to the corporate press release announcing the successful commissioning of this installation. So ExxonMobil hasn't published much about this yet. The stories are, Dave DeBarry is the principal storyteller. I hope they publish more, but this OPA-based system is running a manufacturing facility with a plant manager who's got P&L responsibility, and it's been working fine for the past 3 months. This is a picture of BASF's work. This was work that was done by the German headquarters organization. This was done back in 2017. What BASF wanted to demonstrate was a realization of OPA, a realization of two Namur initiatives that I'll just drop some names here without having the time to go into the detail: module type package and Namur open architecture. It was done, the actual system build was done by a European systems integrator and as well as a German university. Okay. Georgia Pacific, this was done by a gentleman, Carl Cherney, in Alpharetta. He built what he called a demo board. This was, again, fairly early work, 2018, 2019, and he tried to assemble component products from multiple control system suppliers. Not really a full realization of OPA, but it was meant to illustrate the art of the possible. And this board was taken around to paper mills and shown to people about this is what the future is going to look like. I don't know what Georgia Pacific has done with this work since Carl retired. Dow has made a very significant investment towards OPA and like digital twin technologies in a demonstration unit that is in the Chicago area under a government-funded program called MXD, which I think stands for Manufacturing Digitalization. This is a picture of the unit. And what Dow was trying to accomplish with it is to demonstrate interoperability among different vendor products. They wanted to demonstrate the OPA computing framework and also digital twin technologies. And we've had fairly recent discussions with MXD about getting OPA more prominently featured in the MXD testing environment. My company and the other companies that I'm going to talk about in a minute in COPA, which stands for the Coalition for Open Process Automation, have provided prototyping systems and training programs with a market offering that we call COPA Quick Start. So COPA Quick Start is a fully functional system. It's suitable for laboratory use. It was not designed for production use itself. Has a lot of computing capability. The COPA group of companies are listed there, and I'm going to detail COPA in a minute, but you'll see EOSYS is included in that list. And so COPA now has evolved our market offering beyond the Quick Start training system, and we're actually starting to sell and have sold systems for on-process in production use, which I will share some more information in just a minute. So a little bit more detail on COPA, the Coalition for Open Process Automation. So if you remember that chart of the business ecosystem, so COPA is a group of 15 companies who basically span all of those roles in the business ecosystem that I introduced when I started talking about the Open Process Automation Forum. We have systems integration companies like EOSYS, like Wood, like Burrow Global. We would like to add more. Subsystems integrators like my company, CSI, and another company coming out of Silicon Valley, Seaplane, and hardware and software component suppliers like Phoenix Contact, like Stahl, like Novasmart, like Codesys, for example, and inductive automation, which figures prominently in our offerings for HMI, alarming, and historian purposes. We also have some computer hardware manufacturers in the COPA coalition, ASRock and Supermicro most prominently. So this is who COPA is. This chart, which I know is probably hard to read, can be just with the size of these displays, but what I wanted to depict with this figure, this chart, is to give you guys an at-a-glance look at what our experience base is building OPA-based, OPAS standards-based control systems. So each of our companies have development labs. We talked about the Quick Start offering. If in response to questions, I can give you the bill of materials on the hardware and software that's in Quick Start. I didn't put it in the mainstream talk. We are assisting our control systems integrator partners like EOSYS, like Wood, like Burrow Global, getting their test bed facilities up and running. I'm in Dave's shop. Dave, you want to comment on what Chase is doing?
Yeah. Chase Davis, our Director of Technology, who's involved in the technical work group for the open process automation, has worked with Dawn and Seaplane, and we've put together a COPA Quick Start rack in our lab, and we've started working with this. And this is kind of what we see as the next generation DCS, and we're trying to be sure that we're on top of that. And so right now, that's kind of where we're at. We're as these companies are starting to move into this technology, we're trying to keep pace with it, and we see this as a very interesting thing going forward, and we're trying to make sure that we're on top of it. So yeah, we're working on this right now.
Right, and we like to get into a cadence where if you're interested, if EOSYS is your systems integrator, you can go into their shop, take a look at it, kick the tires, talk to people with expertise. We get a project going, we start talking more deeply. That's the vision. Okay, the fourth entry in this chart is we're starting to respond to RFPs and RFQs. So we've done a number of design studies for projects large and small, and I'm going to share some economic case study results with you in my concluding remarks, but I'm also pleased to report that we're selling now systems that are fit for purpose for on-process use. Small starting installations, but last year we built a system for Texas A&M. This is a research facility, but it's going to be basically on process, supporting a small modular nuclear reactor facility that's being built in College Station, Texas. I'm also pleased to report that about a month ago, we won a competitive bid against all the big fish in the marketplace for an OPAS-based system for an oil and gas super major whom I cannot name, but I will make a couple of remarks about that project on the next slide. So this is just some details on our experience based with these on-process systems. So the one on the left is the Texas A&M system that I talked about. Basically, the footprint of this system that we sold them is close to what I have out in the exhibit area. And I realized the only thing I wanted you to pick up from this chart here is this is a real project in a real manufacturing facility. It's about 450 IO. Detailed engineering, the feed study is being done right now, and we will start engineering on that project in a couple of months with an expectation to commission before the end of 2025. And this is a one-page summary of basically our message about what we're offering in terms of OPAS-based systems. So field-proven components implemented in an open architecture against the OPAS standard. That's the tagline. But what are some of the essential characteristics? Decoupling I/O from compute. Okay, I talked about breaking those proprietary connections. Okay, so there's an OPAS industry standard that specifies the interface between I/O and compute. Because one of the business problems maps back to you really don't ever want to replace your I/O. I mean, the motivation for replacing your I/O hardware is in the unlikely event you're going to be replacing your instruments. You're not going to do that on, it's going to be an exotic case that you're going to be replacing field instruments. So on the other hand, you do want to replace your computers from time to time just to keep pace with the capability of the products in that space. So decouple that connection between your I/O and your compute level. Interoperable data communications fundamentally based on OPC-UA. Decouple software from hardware, and there's a couple of sub-bullet attributes there that I won't spend time verbalizing. Portable, reusable applications based on industry standard programming languages, also taking advantage of what we can do with virtualization and containment. Build cybersecurity in by design, role-based access, authentication, zero trust. I could talk about all these things, but I'll only do that in response to questions. We were chatting. I was chatting with Larry before the meeting started. The way we work, nobody brings your IT badge or your OT badge. We just work together to solve problems. Okay, and there's a lot of cross-fertilization depending upon what domain you're coming from. And we just work to solve problems using the skill sets and the technologies available. So we're bringing in a lot of IT technologies. We're educating IT people on the requirements of process control systems. And that's the way we work. So a lot of the improvements you're going to see in systems management and orchestration and patching are coming in with technologies that have been refined in IT service. And we want to generate business value by enabling third-party technology insertion. So that's the essential characteristics of the COPA control platform. Okay, so I'm almost done with my remarks. I wanted to share some economic results now in terms of a benefit study for initial and total cost of ownership. So our customer for this job was Cargill, the big agricultural chemicals company. And they gave us an RFP. They wanted a design and a budgetary estimate for an edible oils plant, 14,000 IO, 4 to 20 milliamp with HART. They wanted redundant networking and they wanted redundant DCN, distributed compute node hardware, and they wanted security level 2 or greater. So that was our design basis. And there were two case studies that were done. So case study number 1 was an analysis that was done by Wood, who was the control systems integrator in this case. Wood calculated an initial and a 25-year total cost of ownership number, comparing the OPA-based system that the COPA team designed against one currently available DCS. Then independently, Cargill produced their own 25-year TCO estimate comparing the OPA-based system that the COPA team designed and costed against 3 currently available DCSs, and they're the results I'd like to share now. So the results of the case study number 1 are in the first table in this chart, and you can read the numbers. Can everybody see the numbers? Okay, so for the initial cost estimate for the system hardware and software, just without the applications or anything like that, the initial cost of the OPA system was about half that of the DCS that it was compared to. When you layered in all the applications programming work and HMI building and such, that was basically at parity with a traditional DCS project. And that was an intellectually honest calculation done by Wood. In fact, they debited OPA a little bit because it was still new to them. Bottom line, the initial project cost for the OPA system was a savings of about 10%. But where the beauty of OPA really started to shine was in the total cost of ownership calculation, where in this case, Wood estimated that the OPA-based system was about half the cost of the traditional DCS that was used for that case study. The second case study was done by Cargill themselves. And again, Cargill used some slightly different assumptions in this case. But so the OPA-based system compared to 3 currently available DCSs showed TCO savings in the range of 60 to 70%. Now, you may ask why. I got asked this question at the ARC forum last week. And we drew this chart for management in the early days of OPA. So if you think about a DCS upgrade project, you basically cruise along, routine maintenance, upgrade, major cost hump. You go along another 15 years, upgrade, major cost hump. The OPA vision is going to change that expend profile. You're going to be able to do your upgrades and expansions incrementally, not these big bang events every 15 years. Okay, and that changes the whole paradigm of how this works. So we want to get away from these big disruptions for control systems upgrades and migrations and make it more of a continuous evolution and an as needed, as justified upgrade proposition. And that's what we're starting to see with these types of analyses. So one other question that we get asked is, who's accountable for system performance? Who provides post-project support? And this chart, again, which just reuses the business ecosystem model, basically single point of accountability for the performance of the system that you get resides with the systems integrator. And the contracts are being written on that basis. There's a separate role for the ongoing maintenance service to your system. Now, it might be the same company, but I know other operating companies that I interact with during the course of my career. Some people hire local engineering companies to provide that ongoing maintenance to your system. So this is what's envisioned for initial accountability and ongoing support of your system. So just to wrap up my remarks with just a couple of bullet points that I want you guys to take away. So this idea, we it's transformative, okay? This is not incremental improvement. The word revolution scares people off. You're still getting a control system. The projects look the same. You're using different kit. The business model is different. But what we're addressing are the root causes of the business problem to decrease total cost of ownership and increase innovation and value generation. The business case for OPA is compelling. Now, even if these numbers are wrong, in the whole course of my career, I have never seen an economic case for action as strong as this one. Even if these numbers are only half right, the business case is still astonishingly compelling. The OPA forum is really driven by the end users. Okay, that's a fundamental principle that we have to maintain. And if you're not currently a member, I would encourage you guys to join the OPA forum. We can talk about that as well. In this talk, I tried to emphasize industry adoption with the pilot projects, at least 10. The operating companies are now starting to issue RFPs and RFQs. And I've shared some information about ExxonMobil Lighthouse project, our project with Texas A&M, our project with an oil and gas super major in terms of systems going into production service. The COPA group, we feel that we're leading the charge on this transformation, and we're ready to do business for production systems. So that's the message and the proposition that I offer to you guys, and I'd be happy now to take any questions.
Any questions? I think this is a, before we let Dom Napoli go and talk about Schneider's, place in this open process in world that we're moving into. But I mean, it's a very different setup than we've got today. It's not traditional, and the companies are starting to move to it. This ExxonMobil thing is a big deal that they've done this year. And I think for several years, I've been saying this is something that's coming. I've been trying to kind of grease the tracks and say, this is the way things are, I think, going to be. And I've been saying, well, it's a few years out. It's a few years out. That's what I've said. It's a few years away. And now I'm saying, I don't think it's a few years away. I think it's here. I think it's starting. The early adopters are starting to put this in and do this. And I think this is the first guys are gonna, like the pioneers, the first guys are gonna take some arrows in the back, I'm afraid. I mean, I think it's not gonna be just, easy, but it's gonna be where you want to be. And we're trying to position people so they can see that as a path forward. And I think this has a place in your planning at this point. If you are looking for where you're headed long term, and you're responsible for that. If you're not retiring in the next, 5 years, this needs to be on your radar. And this needs to be kind of looking at this as, how do we get there? What is this going to do for us? When is this going to be something we've got to deal with? And by got to deal with, it may be the best thing ever. It may not, but it's still coming, and it's going to have to be incorporated into your setups. So with that said, any questions? Ted, hold on. I'll bring you mic.
Well, you would send it. I highlighted the three systems integration companies that are in the COPA group. So, Wood, EOSYS, or Burrow Global. You could send it to my company, Collaborative Systems Integration. But let me elaborate on the question a little bit. Some of the operating companies are asking for guidance on even how to write the bid spec. How to put the RFP together. ExxonMobil continues to be quite generous, and if you were to ask ExxonMobil for an example of how they write their RFPs for OPA-based systems, I think ExxonMobil would be willing to share some information in terms of how do you write that bid spec to get an OPAS-based system. That's how I would answer that question.
Other questions? Yes, hold on. I'll bring you a mic.
Yeah.
down in the Cargill example, they had 3 different DCS vendors and the OPAS solution. I guess OPAS has to go to hardware and software manufacturers for pricing. So
Right.
in that case, were the DCS vendors, who were they? Who were they bidding against? I guess is
Yeah. So this, thanks, Jacques. So I left this out of the main presentation. So this is the hardware and software bill of materials for COPA Quick Start. So we may substitute over time, but this gives you some example of who is providing the hardware and software components. So in the COPA group, Phoenix Contact and Stahl are member companies. We use Cisco. We can substitute for the networking switch, networking hardware. For the DCN hardware, we prefer IPCs. We prefer the ASRock industrial IPCs, and we prefer super microservice servers. Now we find the operating companies actually prefer, and this actually came up yesterday, maybe Dell or HP hardware. So that's substitutable there. And I won't itemize the software, Jacques, but you can see by function and by supplier who's used. Maybe a key question is we actually like the CODASYS software for an IEC 61131 based regulatory control environment. If you don't know who CODASYS is, they're probably without a doubt, the major hardware independent software supplier. I mean, they've sold, I don't know, somewhere in the neighborhood of 6 million licenses for their software products. So this is how the bill of materials would be worked up for a project, Jacques.
And one of the companies you mentioned there, Phoenix Contact, Ghazi, I don't know where he is, but here he is in the back, Ghazi Azadullah, is that right? Ghazi is with Phoenix Contact, and they're a member of the Open Group, and they're involved in this. And I know we have been talking to them about some of the hardware on our system. So thanks. And they have other stuff to show you out there. They've got a booth out there. So it's good to talk to him if you have any questions, and talk to Don. Don has a booth out there as well.
Yeah, we have another question back here.
Oh, Galen's got one too.
Okay.
Well, Galen, do you see this as applicable to nuclear applications? But they're already doing one.
I got a question about fault tolerance and robustness. I'm sure it's configuration dependent, but how does it compare to the traditional, like a dual redundant DCS or a TMR SIL system, like a Triconics or a
Right.
Woodward Governor
Yeah, so
system?
basically what we're using, there's a number of ways to achieve high availability. Okay, you can do it with traditional physical pairwise redundancy. We actually prefer a software-defined mechanism to achieve high availability. So we can dynamically rehost a workload upon a hardware failure with a software-defined means. And we basically move a compute workload. There's always a backup, but it can be, that backup can be running on where you have spare compute capability in your system. So we're taking a software-defined approach to high availability, which is really our lead case. You can actually include fault-tolerant hardware in these systems. And I mean, in my shop, we're also using Stratus hardware. If the operating company wants that degree of risk reduction, you can also do that. Now, we're not attesting that we're going into SIL 4, okay? In fact, safety systems are out of scope. So shooting for SIL 3 is beyond what we're currently targeting. So I'll answer the question that way.
Okay.
Okay.
Thank you.
So one of the online users actually reached out to me, and as far as the HMI platforms, what platforms are being used, and is it Windows dependent? Is it not Windows dependent?
Yeah, we prefer inductive automation ignition. Seems to be the preferred solution in the marketplace right now. I think Ignition, a lot of the IDEs tend to be Windows, but we prefer Linux for all of the real-time components. Now, I can't, whether we're using a Linux-based Ignition platform, I don't know, but we definitely have a preference for Linux over Windows, that's for sure. Okay.
Hey, yes. So how do you envision this system integrating with facilities that have area-based control PLCs, and specifically PLCs for manufacturers that are highly proprietary and have licenses?
Yeah,
I know you mentioned not changing out I/O, but
right.
you know,
Yeah, okay, so I'll make a couple of comments. That's where the role of the gateway would, well, I'm gonna answer your question somewhat strategically. I'm gonna go back. I went through the reference architecture pretty quickly. I usually use it to define terms, but let me go back there. I know this figure is a little bit too small, but in the reference architecture, there is a provision for a profile of the DCN in a gateway service. Okay, so one mechanism for interfacing to a non-OPAS based system, a proprietary PLC, would be a gateway.
Right. And the DCN to their thing
Right.
is going to map to a control processor to us. That's just,
Right.
they take a distributed compute node and that's their controller effectively.
Now, if the supplier of the non-OPAS system really does not play nicely, you can at least get Modbus, and we would prefer a Modbus TCP interface, so you can at least map data. It's like the universal translator. The other thing in the future that you want to think about is this Namur initiative called module type package. And this doesn't help you in the brownfield, but in the future state, if there are still proprietary PLCs in this market, if you conform to the Namur MTP standard, you have to at least expose the internal workings of the control on your packaged unit in a way that it can be interfaced to at the supervisory level. And my company, we're going to bring forth what MTP calls a process orchestration layer product, which is a mechanism for interfacing to a closed PLC type of device if the supplier of said device programs it in a way that conforms to the MTP standard. So coming back to the gentleman's question about bid specs and stuff, particularly in Europe and the German companies, so this is, BASF and Bayer are all over this, their bid specs for the controls on the modular process units that they want to procure will be written in such a manner that the controls on that on that process module must conform to the MTP spec. So that's a future, but that's going to happen. There's a lot of market push behind MTP.
I'd like to take maybe one more question, if there is one more question, and then we'll go over to Dom and let him do his thing.
It's going to take time. There'll be a long period of coexistence under any scenario. And that's a lot of the questions that we're fielding from the operating companies is now, what does the brownfield look like? How can I get on a migration path to get, if they buy into the better future state, nobody wants to do a rip and replace. Basically, people want affordable and feasible migration paths. That's we're all teed up to answer that question.
Oh yeah, and I have given this a lot of thought and have talked to a lot of people about it, and I think the 100% what you're going to see is there's going to be that DCN gateway to the open process system that's going to sit on your Foxborough system, and that's going to be the way that it translates this back and forth. And you're going to run, this is not we're going to come in and take out our DCS
Yeah.
and put an open process system in. That's not going to happen. It just not. It's too big. It's too much. It's too much at one time. It's going to be, hey, we're upgrading an area. We're doing this. This is the direction we want to go. They'll put it in. It's going to talk to your existing stuff. And this is going to be to an established group like this. This will be a piece by piece process that is going to take years to happen. This isn't going to be like, hey, tomorrow we're ripping out, a huge chunk of the plant and we're putting in open process stuff. This will be a migration and it's going to go through these gateways. And I'm pretty sure about that from the things that we've talked to. So yeah, I don't see this as,
let me put a personal note on that. I mean, I've studied the history of these technologies quite carefully. We do not, we want to learn from the lessons of the past, and we do not want to recreate the issues like with Foundation Field Bus, which got over marketed too soon before all the technical proving was done. And we really want an orderly process to introduce this transformation industry. So we're all going to learn as we go. We'll do projects on a risk managed basis, and we're going to climb that learning curve together. That's what it's going to look like.
thank you. I think that was excellent. Thank you, Don. And I'm going to let Dom do his thing. Yeah, 10 minutes, but let's call it, we'll go 13, 12. We'll come back here at 11:30. 11:30. All right. All right. Let's get everybody back in and do this last little run up until lunch. See if we can make this happen. Can you help me with this? Anyone? Oh, they're not going to need a mic for this. Nobody's going to care. Marcel's, that's mine. I'm good on that. That's too loud. A little less. There you go. I got a quick question for you on my thing. It's not clicking. Yeah, I was going to give you the mic here in a second, Christian, before we get started again. Check, check. This is it's like, how do I make this go? It's on this thing. It's just like, easy. How does this help me? What's that? Yeah, I mean, we're going to do this. Then Marcel, as soon as he starts talking, you come up and grab a mic. That'll give us time to work on it. See? Okay. And then I went like here. Did that. And the screens are.
So now every screen's going to be a desktop.
Okay. Yeah. I'm okay with that. And then we just run the slideshow. Yeah, the clicker's good. Do we don't have the, okay, put it in. Okay. Everybody come on in. Let's give him a second, Christian, to get in, and then then I'll give you a minute to speak. Yeah, I think so.
Hello.
Yeah, there you go. Here, you can have this. You guys take it, and I'll do my thing.
Sure.
Yeah.
Y'all got it? Y'all gonna sell APC? You are. You are. I'm gonna get it. I'm gonna get it though. Hey, you need your bag over there. I know. I'm gonna bring this with me. It's full of stickers. Yeah.
We're ready? Dave, you think we're ready, or should we bring somebody else? I just really want to address in very, very short period of time, 5 minutes, okay? And we were reflecting about yesterday, right? The entire day. I think it was great content. It's been an amazing time, just spending time with you all, and I think a lot to learn. I was reflecting a little bit about the questions Q&A yesterday, and Andy and I represent Schneider Electric Process Automation, which is where Foxborough is in the U.S. And our commitment that we really want to make and what we want to acknowledge is that we hear you, okay? All those Q&As, they're very valid concerns. We hear you loud and clear, and I want to make sure that you guys feel acknowledged, okay? And not only feel acknowledged, but, really, we've been here representing our country, and in the Schneider Electric world. And one commitment that Andy and I would like to make as representing leadership of the Schneider Electric North America is that we're going to take action, okay, on the concerns that we heard yesterday, all right? And we're going to be accountable to actually scream to the global organization and represent the user community, from the U.S. perspective, right? I really, didn't want you guys to leave today and go back and think that nothing is going to happen, okay? At the minimum, I'm not promising that I can solve everything, but at the minimum, what I can promise is accountability. What I can promise is that we're going to escalate it. What I can promise is that we're going to report back, and we will make sure that we give you the feedback that you guys deserve, okay? I'm looking at your guys' eyes, and I'll probably leave my contact information, send an email, whatever, but you guys can always pick up the phone and call us. We want to be accountable, and we really appreciate your business, and you guys being here, and we want to make sure that, I'm looking at you guys face to face, and that you guys have our commitment from that perspective. Andy?
No, yeah, you said it very well. The only thing I'll say, we strive to be better every day, and without your feedback, we can't do that. So we're listening, and he and I we're committed. We're gonna take action. So don't ever hesitate picking up the phone, sending an email. We're here. We're gonna respond. We're gonna take action. So anytime.
Absolutely.
Thank you. All right. We're going to charge through this and try to get to lunch because I'm hungry. So these are some Foxborough IA APC configuration tips, and this is the supervisory set point control that you're going to see in your blocks. And a lot of people don't use those, and you should if you can, especially if you're doing advanced process control and coming down into the blocks, or instead of just writing remote set points or whatever. And also, it's a great way to have some available extra bumpless transfer opportunity and options available to you. So that's me looking kind of frightened, and that's pretty typical. So using supervisory set point control, it became usable by humans. It was usable by the gurus long ago. But once they put the auto acknowledge in, because what happens is when you do a supervisory set point control, previously it would go out to the APC system. The APC would do a handshake and it went back and forth, and you had to actually write some custom code or use a system that would do that for you. They took that out. You don't have to have an APC to write to the supervisory input on it's a parameter it's available to you, but it is not connectable. So you're going to have to write to it with an unsecured input if you want to write to it. The PID has two options. You can either manipulate the set point coming into this, or you can set the parameter to manipulate the output. So these options are both available to you in the PID. And the AOut has one option, you can actually manipulate the output. So it gives you a lot of possibilities to do more built-in bumpless transfer. They're there for you. So when you go in here and you want to do something like this, these new modes, you know, a PID, obviously, PIDA, we can run it in manual. You can do it in automatic with a local set point. You can do it in automatic with a remote set point. These are the things you would typically do. You can do it in automatic with supervisory set point. And this is where you actually pick up the additional set point coming in on the supervisory input. You can do tracking when it goes into manual or something downstream when the AOut goes into manual, or you can do tracking with the AOut in supervisory control. And these options are there. So what we're going to kind of show you is the things you have to look at, the block parameters you care about here, the SE, supervisory enable, supervisory set point, the SUPIN, which you can either drive to the output or you can go to the control to like a remote set point. And then you have this supervisory group, right? And the CP has these groups, has 8 supervisory groups. And we have the option of turning on individual supervisory groups. So when you set this controller up, you have to say, hey, he's part of this group or that group, and you have to pick one. Or, yeah, you can only be in one, but you have to pick one that it's in. And what that lets you do is take whole sections and turn them into control at one time. You can say, I want supervisory control group 1 on, and all of these blocks will start going that way. Or 2 or whatever. You get the idea. The AOut has similar, same kind of stuff, less parameters, a little bit less that you can do with that because the fewer options. So let's go over real quick how to configure it. You pick your supervisory set point group, and then the actual control processor has these groups that can be enabled or disabled from there. You pick your option. The options we're interested in are the ones that do not have explicit handshaking. So that's going to be 3 or 4 on your supervisory options, SUPOPT. And 3 lets us set the set point. 4 lets us do a direct control of the output. And then, of course, we can enable or disable individual blocks in spite of the group. And then the set point input is what we're driving through from our APC. So let's take a look at it real quick. We built some screens. We made this work. This is all simulated up and running and actually tests and goes. So I just wanted to kind of show you what it looks like. This is basic. This is the first one we're looking at, I think, has the PID in manual, the output in auto. That's what I'm showing down below those 2 faceplate blocks. And I've done the world's, simplest simulation without having to use Winston or Brian's tools and just loop back I put a lag block in, it goes back. So what we did here, you can see that we're just running and we set the output to 33 and everything comes back, it all works. Then we can put it into auto and local, like I said, now we're just running down the thing. Now the D on the faceplate up here doesn't even show up unless you have a supervisory control set up, the SUPOP, and then you'll see the D, and that indicates that it is disabled. Supervisory set point control is disabled. And on the output, the D is telling you the same thing, that we're not driving it from somewhere else. This is auto with remote set point, same thing. You can see we still have it disabled. Now, we have enabled the supervisory set point control. Again, this can be coming from an APC system, your advanced process control. This could be coming from some sequence logic that you wrote to drive this. This could be coming from OM sets. So depending on how you want to drive this in there, you just can't do a connection to another block to get that supervisory input. But if you have an unsecured connection, it's available. And at this point, you see that we go into E, okay, on the faceplate up there at the top. It's tiny, but you also see that I made my green not be quite the same color green. And because what that says is, when you have implicit handshaking on it, that the block is now waiting to see an output change on that supervisory input to go into a control state. So it will sit there like this, holding its last output, doing its thing, until it sees the supervisory control actually write a value in. When it does write a value in, notice that our little color on the block down there where it says APC changed to green, and the C goes to controlling up there. Okay, at that point, this guy is in supervisory control. Well, okay, what's the big deal? They got supervisory control. Well, the big deal in this is going into, out of supervisory control, your APC, from, if you were to fall back to, in this case, if we took it out of supervisory control, go back to remote, that's based on your local remote switch. But all of this stuff is bumpless. All of your back calculations are taken care of. You can sit there and you can go, I'm in advanced process control, I'm in remote, I'm in local. This thing just gives you all of the bumpless back calculation is taken care of for you. And there is a supervisory back calc that is fed upstream to your APC. So it knows where this is when it takes over. So you can know, where the process is, so that that's bumpless too on the APC side. So all of this stuff is built in and works. Then we're going to go to the next block. Well, okay, then this is where it starts showing more of the features of this stuff. We put the output into manual. Well, you got a PID controller, and the PID controller is in supervisory control. So that PID controller, if you've got it set up like we do and like you want it to be, it goes into tracking, and notice that instead of being in control on the supervisory system, he says, well, we're enabled. If this thing comes back out, I'm going to let you go back to it. But at this point, again, what we're trying to show is the fact that all of these interconnections are all bumpless, they're all built in. So now we go to APC. Well, if we grab from the APC the A out block, not the PID block, we're not working off the PID block, we're working off the output block, and we're going to let the APC just manipulate this output. Once again, when we do that, and this is in a different supervisory group, and I did that on purpose so that I could manipulate the output independently, you can see that when we turn the APC on, the output goes into E for enabled, and the PID goes into E for enabled, and everybody is just hanging tight until the supervisory control writes a value down to that analog out block. So at this point, your process is saying, okay, I'm waiting for that guy to tell me what to do. As soon as we make a change, I change the output from 33 to 40. As soon as we make a change, we go to controlling on the analog out. So now we flip this guy. Maybe you've got two loops. You've got two advanced process control constraints you want to work with. This guy can now drive the analog out. We're still in a good spot on the PID. And then the next part of this is we flip that guy back into auto. Hey, look, I mean, without anything else, we just said we don't want to be in supervisory control in the output. The PIDA is back to state enabled, but as soon as we did that, he came out of tracking, and he's waiting for that APC to write a value down to him. As soon as that value changes, he goes back into control on the APC. And all of this stuff is again, it handles it very well. These set points, these blocks, the way they track, the way they come through. So, you have an option there. You can actually work the output directly, manipulate it. And so it gives you a clean way to set up multiple inputs into that system. So I'm going to just jump out because I don't think that's worthy of any questions at this point. Marcel is going to talk to us. Oh, and these two topics are related. This is why we got them all together. The APC, a lot of people are using OPC and we're now going to be talking OPC-UA. That's what this topic is. But most people are using some kind of OPC to let their APC. That's great, man. We got enough acronyms yet. The OPC to the APC to the OPC to the CP is, that's the the manual. But that is why this is in this topic, because these are ways you can get down to those blocks. The next thing I'm going to let Marcel talk about is Foxborough Schneider now has an OPC-UA server. And then when they get done to that, Kevin White and I are going to talk about the OPC-UA client. Both get a microphone. Yeah, if you step over there to Matt, he'll give you a microphone. All right. So the OPC-UA quick reference. This is Kevin White from Alabama River. I appreciate him coming up here and helping out with this. He has did the heavy lifting for down there. And Arlie Bright, who is so smart that he doesn't even come to these conferences, did the heavy lifting for us. So I'll be playing the role of Arlie in this. And that's why when I get confused, I'll just look at Kevin and go, I don't know, maybe Arlie knows. But it's okay. So, but I was involved in the beginning, and I did help them decide to do this. And the reasons we chose the OPC-UA client, and I kind of talked them into choosing the OPC-UA client. Well, they had prior experience with OPC Classic that Marcel was talking about, the DCOM version. They had it, and we knew that. DCOM has inherent security problems. You actually have to put tunnels in. There's a lot of stuff. OPC Classic is not the way you want to go. That part I'm convinced of. I mean, if you have it and you can keep running it, that's fine, but it's not going to be there for a long time. The OPC-UA client ran on an AW, which worked fine, but occasionally an AW requires reboots, and when it was rebooting, they had to go down, they lost the connection. We said, hey, if we could take that and put it into a FDC 280 that doesn't get rebooted very frequently, should be up all the time, and it's going to be able to be secure. It looks like a way to future-proof this gateway. Going forward, this is, we think, and everyone else is saying, the technology to go with. And more OPC-UA compliant products and packages are coming on the market. Again, that's the direction things are going. So we went ahead and did this. And so to do that, we got an FDC 280. We got the OPC-UA client. And then we'll kind of let Kevin talk about it, but installed it. And you can talk about it. Ran for a while.
So the initial setup, it normally ran, well, we use Kepware to communicate with the FDC 280. The initial setup, it normally ran about maybe a week, and then it would stop communicating. And now we're running 40 days plus. So you can go ahead and go to the next slide.
Yeah. So, okay.
So to set it up, really you have to use UA Expert as I guess an interface in between your server and your client. So to set it up, you have to go to your custom discovery and add a server, and you will need your IP address from your server and the port number. Okay. So from there, you need that's where you get your extraction from your server, and that's where you'll get the namespace array to actually link the client to the server.
Yeah, which is like not very seamless, right? We got to call up this OPC-UA expert, and then we got to browse out there to an OPC-UA server, and then you got to look in this description field, and then you got to look at array element 2, and then you got to take that information, and now it's going to go back, and this is where I was talking about them kind of scabbing on stuff on these controllers. It's like, guys, really? We got to go drill down, use these other tools, get this information, and now we're going to put it back into the Galaxy.
Yeah, we'll be
basically.
back here.
Yeah, we'll be back in a minute.
But now you have to go under your network tab on the Galaxy to drill down to your FDC 280 and get to your Ethernet port. I think you can go ahead and go.
All right.
And this is where your namespace 2 would come in. So this is setting up a group for, I guess, server to client communication. So you set up your group name. We left the scan rates in phase at default, but custom parameter 1, that's where that namespace 2
That's
Yeah.
the, yeah, the
Yeah, it comes into play.
unified resource, I don't know, it's not a URL, but it's basically where it can find that OPC
Yep.
server to get that information from. So you have to fill that in from what you got out of the UA
UA.
expert in that description.
That's right.
And then,
So for your IO point aliases, so the name is really just an alias colon data type. And then the address is where you would have to go back to the UA expert and kind of go through and find under real-time data in the expert tab
right,
and pull that. And your group would just be the group that you just previously made in the group tab. And then the data type would also come back from UA expert.
yeah, and I believe, this is from our little testing we did the other day when you and I were going through this. We think that, because I have always been, I won't say we, because Kevin may know, confused about the fact that when we're putting these names in, we're putting this :s at the back of them. And I think what's happening is when it gets this point number, it's resolving that, and it has to know that it's a string. And it's just, it doesn't tell you what the data, like you build a RIN block and you tell it the tag name is, LT100:S, and you're like, why am I telling it this is a string? Well, it's going
Well-
through this lookup, I think, with that.
Well,
Point
I
number.
think the string part comes from the UA expert. So
Okay.
it's somewhere in that configuration.
We're not really clear on that.
Yeah.
Okay, and then now we're gonna add a tag.
Yep.
So you gotta go in here and,
So under your tags, you go to the inputs, and you can go to the next
all
slide
right,
to open up an overlay that kind of sets up you'd have to assign the tag to, I don't know what the best way to explain this piece of it, but you'd have to assign that tag to the point number through that next tab.
right. So
Yeah.
when you go to the IOM ID, yeah, let's go back a couple. Like right here, when you pick the ECB identifier, if you pick these 3 dots on there to do your thing, then it's gonna come down and it's gonna go to this set of things you pick from, which is, again, brought up by that. And then you're gonna get that, double click that where you want it. And then you're gonna go to a second window that puts the tags that it knows about from
That's- From the IO point aliases, and then you'd have to select whatever tag it is to assign it to the tag that you just created, and then it'll
And then
auto generate.
and then it puts it in the fields where, like you would expect it to. And then ta-da, and as we said, could it be any simpler? Well, yeah, it definitely could be simpler. We just went
Yeah,
around the world to get this information and put it in there. I mean, this is like, does it work? Yeah, it works. I mean, we were able to make this work. Does it seem to be, is it understandable? Once you understand the process and go through it a few times, yeah, it's not terrible. There are bulk generation tools to build all these tags in and set them up, So, I mean, I'm not suggesting that this is not something that is, well, I don't know what I'm saying. I'm saying that the tools are not where they need to be for ease of use and being able to go down there and get what you want. The parts and pieces are there, but you're kind of like, it's like, the difference between going and buying a little car for your kid that's all in it, ready to go, and going like, here's a model and some glue, spend the next 4 or 5 hours building this piece so that the kid can have something to play with. And I think we're at the model stage on this, and I would like to see them take these tools, because all of this stuff is you doing the stuff. And then certificate generation which we didn't cover in this, is another tool.
That's another journey.
Yeah, it's another journey to get your OPC certificates generated so that you can get those installed so that you can have secure end-to-end communication. I mean, again, is it there? Yes. Does it work? Yes. Is it easy? No. And it should be easy. This is not something that they, should just gloss over like they do. So I think that's all I've got. You got anything else? Any other comments on this or?
I'm good, thank you.
Well, thank you. I'm good. Thank you. Yeah. Yeah. Go ahead, Galen. Well, I don't know the answer, but here I'm going to suggest an answer. I think that a lot of the reason maybe that they have all these weird auxiliary scabbed on things is so that you could use this to get everything back into ICC, if that makes sense. Like you got to go here and get that. Okay, I could copy that into ICC. Go here, get this. Okay, I could copy that into ICC. But I don't know the answer to that. We didn't try to run it on ICC. Yeah, Tom. No, it's running in a Galaxy. It's control editor. Yeah. Oh yeah. No, I mean once you build the tags, it's good with it, whatever. I mean it's a Foxborough tags you're building, and it's on the compound block parameter. You get that communication, and you can do whatever on that side. But to generate the block and get all the stuff done in the FDC 280, we're doing that in the Galaxy. So I don't know if I could do all of that. I'm gonna hesitate to answer. We've got 40 something days of it running. We've run ours in the lab, but we don't have as much traffic and stuff. We didn't see the first problem you guys saw, so I can speak to that. And I don't know. We don't even know what really caused that. So to answer that question, we got 40 something days of continuous operation, and it hasn't. And I'd like to see how long we can go, without it failing. But it seems to be at this point pretty reliable. Let's say that. Go, Kevin. Yes, we can. I got the new UA server in the lab this week. And we can try it with the Foxborough UA server in our lab, and we can test that because we're still running the FDC 280 client, OPC-UA client in our lab right now. So, yes.
Question or problem I have.
Yes.
I'm used to the Foxborough company that guarantees their stuff works and works reliably. And if I have something, it ran for 40 days, hopefully it'll run for 45. That kind of makes me very nervous. I mean, the journey why we went down this road in the first place.
Yeah. Well, I mean, I think Foxborough would say it's reliable. Would I say it's reliable? Well, it's worked for 40 something days. I mean, I'm kind of in a, I'm learning this. This is a new product for us, and it's realistically a new product for them. I mean, if you look at how long they had that driver that we got, you guys were down in October. I think September. It was September, and Mickey would know because we were there. You guys were down in September, and we loaded a driver that, and Arlie's not here, or he would know, but we got that driver for the lab like the week before y'all's outage to load that driver. And Scott Landry, thank goodness, he did load the latest driver. So I can't say that this product has had a lot of runtime. The driver we've got in was released in September. I mean, it was really the week before y'all's outage. So we'll find out.
I'm not going to beat a dead horse, but 400 days to me is reliable, not 40.
Yeah, but I haven't had 400 days yet. I mean, it's run 40, and we haven't had a problem. That's how long we've been running it. So sometime in December is when we got it all working and have had it up and running. Yeah. Yes, 40 days and 40 nights. Yeah, that's correct, Galen. Yeah. Brent?
Hold on, Brent.
Yeah.
Is it just configured through control editor, or is there an additional configuration tool you have to use, or how did y'all do that configuration?
Okay, you got to load this OPC-UA expert on your AW, and then you have to load another configuration tool for their certificates. There's this get certificate thing, and then so all of they're all come with the kind of installation package, but you're loading these additional tools.
That's based on your server, though. Like, you're not configuring anything about your client. in those software.
On the
You're just discovering what you need to type in your client.
Well, the certificate stuff is being pushed into the client so that you have a working certificate, and now those tools are put on there. And so, yeah, if you knew the URI, which Kevin and I talked about this, if you knew the URI ahead of time, you would not have to go discover it. And you would probably know that, to be honest. I mean, we're screwing around with some test stuff, so we had to go hunt for it. So if you set it up, like your IT department said, here's your OPC-UA server, and here's the URI for it, you wouldn't have to go use UA Expert to discover that. And then as far as the next part of it is getting those tags. Well, if you're going to use the tags in IA, you are going to have to know that tag name, and you still got to put that in. Now, there's a bulk generation tool that comes with it, but you've got to run that and have it there to pick from.
That is in Control Editor, though.
It is in Control Editor, yeah.
Did you say what your server?
It's is it standard or any? I think it's standard. Is it the tools, like all this stuff that you run? I mean, everything but the certificate generator, I think, is probably already there. Yeah.
Did you say what your OPC-UA server was
And
and what it was talking to on the
well,
other
I think
side?
right now we're running Unified Automation OPC-UA server for test. He's running Kepware, and they're running a test. So in our lab, we're running a different brand of OPC-UA server than they are running at their site. And now we have the Foxborough OPC-UA server beta that we will be testing it against as well. So we now, if we do Foxborough, that'll be 3 different OPC-UA servers that we've tested the OPC-UA client against. It should work with any of them, but I will at least tell you that it does seem to.
What's on the other side of that server? Like, what's the device that you're trying to read or write?
Oh, it's on the OPC, on the Unified Architecture OPC-UA server. It's a test. It's an OPC Foundation test set of tags that
So
just
just
generate.
simulated tags. There's not a real PLC or
No, but the
anything.
tags are, well, I mean, they're not the values in the tags are simulated and are being generated on a updated basis, like every couple seconds or a second or whatever, and we're watching that. All right. Well, the good news is we're not that far over, I don't think. And lunch is upstairs. If you guys head that way, you can grab, like I said, I think if you want a soda, I think there's tea and water upstairs, but if you want a soda, you probably want to grab it out of the cooler on your way up. There's supposed to be tables up there for us. And we will meet back down here. Let's try to cut lunch a little short and get back down here kind of on time. Thank you.
So I'm here with Bob. We'll introduce ourselves. Yours on. So we're going to talk a little bit about a project we EOSYS did with Galloway, where we were looking for high performance graphics. I'll stand here, I guess. High performance graphics and some of the lessons we learned. I'll let Bob introduce himself first.
My name is Bob Jones. I'm one of the controls engineers at Galloway Company. Pardon me. At Galloway Company, we make ice cream mix for a couple of the bigger players as far as fast food chains in the USA. We make sweetened condensed milk for the candy and the pie industry. We're not a name that you would see on the street. Everything that we sell to our customers, they then in turn make their customers happy. So a couple of years ago, I came on board, and shortly after that, this project was already in the planning, but shortly after that, we started looking at, from a company perspective, we started looking at standards, programming standards, HMI standards, and that's kind of, we were already a business partner with the EOSYS when I started, and that's kind of how we got started on this path.
All right, and I've given a couple, so I won't say much. I worked for EOSYS. I was the lead engineer on this project, so we worked closely with Galloway and their engineering team. I'll leave it at that for this. So today, we're going to talk about high performance HMI. but not going to go into a lot of detail about what that means. The focus for this presentation is really going to be the lessons we learned with working with the operators to get buy-in on this, what things we did that worked and didn't work. That being said, I'll have Bob give you a brief intro to the project just so you're not lost when we're talking, and I'll give a short 5-minute introduction to ISA 101, which is what I am talking about when I say high performance HMI. And then we'll talk about design and getting operator feedback. So Bob.
Yeah, okay. So I already gave you a little bit of intro about Galloway. Jumped ahead a little bit, but basically what we did was an expansion for the company. We added a new evaporator. Evaporator is what we use to make the sweetened condensed milk, the products that go out and make candy and pie and all the good things that everybody loves. So we have an evaporator, and it's probably the biggest department we have in terms of pounds of output. This expansion project was contrived, gosh, I don't know how many years ago that Galloway's even been thinking about doing an expansion like this. But like I said, shortly after I came on board, this was for sure happening, and we started down this path. And we knew that looking at programming standards and HMI standards, that we were going to go with Control Editor and Control HMI. And ISA 101, I did a little bit of research. I joined ISA for just long enough to download some of the standards and do a little bit of reading. And you'll see here when we get to some of our screens, you'll be able to tell that it was heavily influenced by those standards. I had somebody ask me at lunch, say, "Oh, you bought into the gray HMI scheme, huh?" And
Don't worry my thunder, Bob.
Yeah. so just be ready to go down that path, because I know that's what everybody's thinking.
So ISA 101 basics. Let's start with, what is high performance HMI? You've all heard that term. Somebody tell me. Not you, Dave.
It gets another award.
We don't show anything on the screen, and there are no alarms.
Everything must be good.
And I'm gone. No. Anybody? Who's done a high performance HMI project? So you've started. What did you do to go to high performance HMI graphics? Okay, so grayscale. Was there any other Yep, menuing. So let me talk. I'll take at least part of that answer is what I was expecting to hear. So this is a screen that Galloway had for their existing evaporator that their operators love. Do you know how many times I got asked for this screen to just be the same? And then how many times engineering there's a button on this screen that you can click. If you don't know how the screen works, a little star floats around the screen and shows you the process path. And I've clicked it many times. So high performance HMI, if that's what you said first, is the first thing everybody says, it's grayscale. Get rid of the color. So if we do that, we end up with this. So now everybody knows what's going on in the screen, right? It's grayscale. There's no alarms. I guess you know that much, probably. The other piece that people say a lot is to get rid of the 3D objects. You see a lot of realistic looking graphics. So, this isn't great, but I took Visio and I said, okay, now I've gotten rid of all my 3D objects. Is this a high performance graphic now? Still not. So if there's one thing that I can get you to leave here and remember, is that ISA 101 and high performance HMI is more than just grayscale. I'm next. And I'll just say I'm not going to go through the standard. We talked about a few points of it, but the biggest misconception is that ISA 101, which is, I didn't say specifically, that's the ISA standards for developing HMIs. It's not a list of rules. There are very few things that it says you cannot do in the standard. What it is a guide through that process. It tells you, you should think about how you use color. You should think about how you navigate between screens. You should think about all these things and make decisions that help your operators. So at a very high level, it goes through and it specifies in blue here an HMI philosophy, an HMI style guide, and an HMI toolkit as kind of the starting of this process. You go through those, and two of those are documents. The third is your HMI library. It talks about designing HMI screens. What kind of questions should you be asking? How should you think about these problems? And then lastly, it goes past installation. How do you maintain and manage these HMI graphics going on? So point number 2, same as just grayscale, is that if you only take part of the standard and try to apply it, that's where you end up with your operators saying, I hate these gray graphics, because all you've done is change something without giving them any of the other conversations and designing that really goes into high performance HMI. It's not about any one part of the standard. So Bob, I'll let you talk about as we went through this project.
Okay, so we kind of knew maybe to some degree what the screens were going to look like, but David did a good job of coming on site and starting with the operators. For one, I'll say one of the company owners, our company owners are still, there's still some of the Galloway family members in the company. This is a pretty small company. And Todd Galloway is pretty insistent upon, hey, you got to interview the operators. You got to make the operators happy. Like this has to meet their approval. So David did a good job of like starting sort of an interview process, or just working with them to say, hey, what do you need? How do you start this whole thing off? You start by making a blend. And so what screen do you go to for that? And show me what you need, and show me what you do. Show me what you push. And along with that came just the display hierarchy, how you get from one screen to the next. And so again, following the standard, level 1, 2, 3, and 4 screens. We had to consider alarming and the use of colors. The colors kind of coincided well with looking at the HMI standards. We looked at what was available in Control HMI. And so we took all the defaults there as far as colors for each of the alarming categories. We looked at how much information was on each page, trying not to overload the page, like you saw what the first evaporator looked like. I think for most people here, that was like information overload, but again, that's what they grew used to, so they loved it. How did they interact with that screen, even though it was busy? What did they really need as far as interaction? What caught their attention? And security. Why do we have security on there?
Because you should have security in your HMI.
Yeah.
So these
but
these
like it
talking
didn't play
points
into...
are straight out of the standard. It has a section for each one of these. And I think my next bullet point I put for you is that you may not focus as heavily on each area of this. In particular, we called out consistency, use of color, and information density, meaning like how much information is on one screen, and can you actually process all that information at once?
Yeah. So, to your point, what you're saying is the biggest ones are the hierarchy, how you get around from the screens, the use of color, and how much information is on each screen. I understand why security's on there, but it didn't really influence us as far as like, it is part of the standard. It didn't influence sort of how we designed. So let's
Let
see.
let me interject one more thing. So this is the HMI philosophy. All of those, we weren't necessarily making hard decisions in this HMI philosophy stage. It was very much talking with operators, talking with engineerings, deciding like what your goals are, where are you trying to get. Not necessarily we'll use gray number 7 as the background. We're not to that point yet. It's very philosophical at this point.
Yeah, the philosophical part was hard for me because, you know, like I'm an engineer, and so there's one of the owners saying, "Hey, go get all this input from the operators," and I'm like, you know, you could put quite a few operators in a room and leave them together for a long period of time. Would they ever come up with HMI 101? No, they wouldn't. But so it was hard to say. They'll get used to what we give them. That's what an engineer thinks, and then, you know, an operator's like, "No, you have to give me what I want." So yeah, we considered a lot of things going through this. Okay, so the display levels are, again, pretty much straight out of the standard. Your level 1 displays are going to be sort of your KPIs or your sort of a process overview. Your level 2, David brought some analogies in here from a car. It's like a car dashboard. It's got a little bit of information, but if you're just looking at the basic instruments, it's not information overload. So it's just a sort of a light level of detail. Level 3 display would be like looking underneath the hood of your car. You get to see a little more detail. You get to see a little bit of the nuts and bolts and what's going on. And level 4 is like you're digging into the repair manual. You know, you're really maybe you're manipulating something manually, or you know, you're down to the nitty-gritty level or down to a device level. So the navigation is basically the higher level displays will have links to the lower level displays, and you'll see here, we'll get to, when we show you one of the displays, there's breadcrumbs that we can get quickly. If we want to go up a level is quite easily. Down a level, you're back to information that's on the screen, and you have to click from there.
And just to interject this most important part one more time, this is not, you know, it's called a standard. None of these are hard rules from the standard. The standard is you should decide on how you're going to organize your graphics. You should decide how you're going to navigate. And it gives, especially navigations, it gives 4 or 5 different common navigations schemes.
The background is a light gray. So just like Rick pointed out, thank you, Rick. So basically, it just makes a consistent background color that makes it possible to make the colors that you might want to use stand out. Equipment state, basically we chose white for active. If a motor was on, it showed up white. If a valve was open, it showed up white for the path. Dark gray was, you know, deactivated or at the off state. Light gray was something that was not automated. And again, to drive it home, we didn't use alarm colors anywhere. If it was a color associated with an alarm, we did not use that on the screen. Text colors, blue for process values, dark gray for labels. I think those are right out of the standard. I think there is other manufacturers even. I've read the Siemens guide and the Rockwell guide, I believe, also follow the same strategy. I don't know if you guys ever dealt with those, but let's see.
So the Rockwell guide and Aviva has the same thing. It's called a style guide, so it's the same thing we're developing here, except, you know, the one we wrote was specific, like Galloway's standards. I do want to counter argue what I just said. This is one of the few places in the standard that has a thou shalt not, if you will. Your alarm colors in the standard says are not to be used for anything else. So this is where you get into arguments with operators. What's a stopped pump in your plant? It's red, or, you know, maybe an open valve is red if you're in power. So red being the stopped and the alarm color is like the main thing you'll argue about. But it really is so that if you see red anywhere on a screen, it's a problem. Aviva kind of pivots a little bit on this in that they use some weird colors for their alarm that you probably aren't already using. But yeah, alarm colors, don't use those. And then the other piece of that is red, green colorblind is, I don't know, like 6% of men or something. And it's, you know, enough that I've not been in a plant that didn't have at least one operator that was colorblind. So that's one of the only one we're going to talk about today, the thou shalt nots, is those two uses of color.
Guy, there wasn't any violations that we really had in mind, you know, for what we were doing as far as violating any standard. Specify how each alarm level will be communicated to the operator. So we know what we came up with was, you know, like how an alarm will be enunciated, like, you know, what will be colorized basically. Again, the color of each alarm level, we just went with, instead of getting in there and changing anything, we went with what was already in control HMI. And then which alarms are visible on level 1 and 2 displays. And we took into consideration how the alarm groups will be used. And the current alarm display is open on request. You know, it stays like a ribbon at the top of the page. And let's hit next slide.
The key thing here is that we're not talking too much about alarming. That's a whole topic. And that a couple of those topics, you got to think about the environment that the operator's sitting in. You know, it's very easy. In fact, even though I put it on this slide, we didn't do this very well on this project. We designed all the screens on one monitor, and then we went out in the plant and they've got 4 monitors. What are they going to keep up on those 4 monitors? That's the kind of things you need to think about as you're developing your style guide and developing your screens. We're off to me. So once you've kind of figured out the, you know, we use Lighthouse a lot in today's age, but the philosophy is kind of your, where am I headed? Your style guide is like, what are the rules that I am going to follow? Now you've got to develop your toolkit. So this is really where I think if you're going to try to go to a high performance HMI process, this is where control HMI does bring a lot to the table, which I'll touch briefly on, not as much as I would if you track me down later. But basically, creating symbols is a lot easier in control HMI. It's a lot easier to deploy those symbols and have them update screens. So just an example of, you know, 5 random symbols that we are in our toolkit: a discrete valve, a 3-way valve, pumps, process value, PID loop, and that last one is like a phase status symbol. So another thing that control HMI and control editor kind of makes easier is if you're using device templates as well, we talked about yesterday. It's easy to marry up your HMI graphics with a device template. The one missed opportunity I'll feed back to Schneider here somewhere is that if you've done Aviva development, there's very much this concept of marrying your graphics to a template, to an object, and that's not really supported with strategies. If I would ask for one thing with control HMI, it's to be able to build a symbol on a strategy template. So a couple other just categories of things that you'll want in your toolkit: supporting symbols, buttons, navigation flags. It's easy to develop those in control HMI, and it's easy to use them. And especially buttons, we all have been in screens where you don't know what a light gray color on your button means, because over here that means I can click it. Over here means it's disabled. So element styles is another feature of Control HMI. There are a bunch of element styles, which if you're FoxView, Foxdraw, it's like conventions, but better or easier to use. You know, you don't have to copy some random file, go look up the manual. You can configure your styles. So some of the built-in ones are the active element style. So I'll contradict you a little bit, Bob. I don't know if you realize we did this. We didn't use the built-in colors. The two that we swapped were active and passive. The default was dark gray for running and white for stop. So we swapped those in the element styles, and then it updates everywhere that you're using that element style. Yeah, so I list a few examples. Active, passive, label, so that your text size is consistent for like a device tag. Actual values, you can kind of pick what is part of your style. Font color, font background color, font size, all of these things you can have be part of that style or just leave it off, and then you just set it on a case-by-case basis. All right, so now you've got your standards, if you will. It's time to go figure out how well they work in the real world. This is potentially your first project. So I'll be repeating Bob a little bit on some of this stuff. The first thing we did for this project is I went out there and we got in a room with operators. We scheduled time with 3 or 4 different operators on the process. And, you know, a little bit of it is they're nervous about this high performance HMI thing. So you gotta talk to them, and we all know how that's gonna go. You're gonna have some people who you have to keep awake because they don't care one way or the other. Some people that are just nervous and resistant to change. If you're lucky, you might have somebody who's excited about what you're gonna change. So first, just, you know, this philosophy is a really good tool for kind of getting buy-in early. And then as part of designing the screens, now we're talking project-specific conversations. You know, I just came up with as many questions as I could just to get good responses from the operator. You know, I didn't go out as like, what should the screen look like? That was not one of my questions. Instead, I said, you know, pull up their existing screen if they have one. What's going on in this screen? And just this is where your, you know, non-engineering skills come in. You have to listen to them and figure out what they're doing, what their pain points are. A few example questions I put on here you can get in the slide download, but, you know, what do you need from the HMI? How do you run this process? Very much kind of open-ended questions, and just see what they think is important. Yep. Last 2 topics is, you know, and if you can get out in the field and see them run their system, that's always better. You know, if it's a green field or a new process, you can't always do that. And then the main thing that you got to keep in mind is this is the part where you're getting operator buy-in. It's not after you install it. It's not, you know, as you review screens. It's before you make your screens. You're involving your operations, your engineering. So you can hopefully save yourself a lot of heartache early on. So this is our process. Hopefully that picture will change as I talk. Well, we'll see. So all this operator interview, we had those discussions, I took notes, and then we got a whiteboard. And this is really like what I encourage you to do. The point of these pictures is that my handwriting's terrible, my drawing skills are terrible, but it doesn't have to be pretty. It shouldn't be pretty. It's better if it's not pretty because you're not designing the final screen. You're just brainstorming ideas. So the first step in that you can kind of see here, I'm trying to draw like the navigation hierarchy. These aren't detailed pictures of what exactly is going to go on every screen, but it's like, okay, I know I'm going to need an overview screen. In level 2, okay, what are my big areas? What are my units maybe? What are your areas of the process? And then level 3 is kind of the, I think Aviva calls that the unit, like a tank potentially might be a level 3 screen. So list that out and ask your operators like, okay, this is an evaporator. If you're looking at this and you need to know quickly what's going on with the evaporator, what are the 3 things, 5, however many you want to do, what are the 3 things you need to know at a glance? And do that for each level on each screen. Then after you kind of have an idea like, okay, these are what my screens are going to be, start designing those screens. And again, this is a little bit bigger picture, but it's still not pretty, still not detailed. See, this one's scrolling through. For me, what worked best was starting with the level 2 screens, because, you know, if you already have FoxView screens, maybe the answer is a little bit different. But for us, this was all pretty much new. And level 2 is really where you want your operators to be the most of the time, right? When you're driving your car, you don't pop the hood to see exactly how much gas you're giving it. You're looking at your speedometer. So that level 2 display really, like, I think drives the conversation the best if you start there, because that's where you want your operators thinking of as being their main area to work. And then from there, you can take your level 2 display, you can identify the specific pieces, major pieces of equipment there. Each of those becomes a level 3 display probably. And through this process, one of the big themes, I guess, of ISA 101 and high performance HMI is kind of getting away from giving a bunch of data. Like, you don't want a screen with a bunch of numbers on it. There's only so many numbers they can read in a short period of time. So one of the big things that the situational awareness toolkit gives you is the ability to have like the vertical bars, trends. There's a lot more, especially trending. FoxView's pretty lacking on what you can do with trending on a display. So I included a few pictures here of like just how could I show this information in a way that makes it easier to look at a glance, easier to give you the information you actually need without just listing out every level 3 process detail of it. So that could have been a whole presentation by itself, but we came out with these whiteboard designs of what needs to go on a screen. And then HMI development, you've got your toolkit. So hopefully this is pretty quick. You start building those screens based on the whiteboard. And I mentioned here the situational awareness library is included in Control HMI. So a lot of these symbols you're seeing, the vertical bars there, horizontal bars, a lot of that is based on the situational awareness library. You can duplicate that and customize it a little bit, but it gives you a lot of good starting points. And then lastly, through this whole thing, again, one of the areas of projects we didn't do that well was going back to operations. It's always hard for us. I imagine it's the same for you guys to pull operators from their daily activities and get them to be dedicated and focused to a project that's not going to finish for 6 months. But really, you know, you'll save yourself time in the long run, as we've all learned before. And the last comment I'll make on that is, with high performance HMI, it's very much not like, okay, we've designed these screens on the whiteboard, that's what you're going to get. It's very much prototyping, showing them something, listening to what they say, coming back with something different, offering up different ideas on how best to give them the information they need.
go back up one slide just for a second here. Where you see this evap down here, and then you got evap effects and evap tanks. So this is kind of cool. This is one thing I like about this is that if you see just evap, that's a level 1 screen. If you see evap and then something else, that's a level 2 screen. So just let you know the layout here. This is flashing in front of you if you just want to kind of make sense of what's up there.
I'll come back to the screen at the end when we do questions.
Okay.
So everybody can.
Okay.
Look. Yes. Yep. So, the standard does talk about this a little bit, and we did push that because this was very much, if I went back to the pod screen, it actually started in the bottom right. I'm sure all of you knew that when you saw the picture that it started in the bottom right and went clockwise around the screen. We very much tried to design these screens to follow left to right, top to bottom, as far as the process concerns. Sometimes that can get a little crossed, like in particular here they had 4 effects. So steam goes through effect 1, 2, 3, 4. Product goes 1, 2, 4, 3. So you get in those situations where it's kind of a, one way or the other, neither one's wrong. But definitely try to be consistent with that left to right, top to bottom process flow. That's a good point. And again, I didn't talk nearly enough about the standard. That's, could have been a day's worth of talking on its own. So throughout this whole process, you're going to be constantly getting all types of feedback from your operators, good, bad, and ugly. And what I found throughout this whole project is, I've done projects where the answer to any kind of negative feedback, because there's going to be a lot of negative feedback. I don't like these gray colors. I don't like that pump symbol. This is what we have today. The first thing you can do that is wrong, is not good, is to always, they come back with feedback and you say, okay, I'll do exactly what you just said without questioning it or pushing back on anything. This will make your operator happy, but you don't get any of the things we're shooting for in our HMI philosophy that we thought were important in our HMI. So the other thing that I've seen that's all too common is not listening to them at all and saying, I can't do that because our style guide says we don't show numbers on level 1 screens. So this is where it gets tricky. Again, our non-engineering skills, you have to listen to what they're saying and why they're asking that question. There's a reason they want that number shown, So in particular, if I go back to these level 2 screens, we went through 100 different versions on every one of those. Once the operator started looking at them, once they started using them, and we found, what are they complaining about and why? Like, what do they really need? So, and again, if you've talked about your HMI philosophy, you have something to come back with and explain why you don't want to give them exactly what they just said. But if you can do that and then acknowledge like what they really need, you do need to see the status of that pump here. But I don't just want to drop the pump on the screen with the amps, torque, and whatever listed right next to it. What's the piece of that that's really important to how you run this machine? So I think I did okay on time. We started late, but I think that leads us to key takeaway number 2 is looking for ways to give them that information they're asking for, even if it isn't the first thing they ask for. Have those conversations, iterate it through with them. All right. And I've done a bad job of pointing this out. So before I ask for questions, I'll point out that all of our presentations had a survey to say if you wanted to give any feedback or, there's part of this you thought should have been in the presentation or you didn't care about. I'd love to know. So that's for the conference. This is specifically for me. So if you like this presentation, act now. If you didn't like it, I think there's cookies in the back or something to distract you.
I want to say one more thing before we take questions, but there was a moment in which we were beginning to bring equipment online. We were starting to run some things, and it was engineers in charge. And there's a quad set of monitors there, and we're kind of controlling things. We're checking things out. I forget at the very moment what exactly we were doing, whether we were bringing up a section or we were doing some kind of I/O check or whatever. But the operators were starting to be, sort of be around. They were starting to take up the space, and they were kind of watching what we were doing. They were curious by this point. And so they were maybe 4 feet in the background. And again, some engineers are at the control. And so they're saying, I'm not, there, a lot of apprehensiveness. I'm not sure I like this. You're not showing me this. And I can't tell from a distance, all these things. And so at one point in time, we were running things, and one of them steps up and says, hey, look at this temperature. It's doing this, so they're already they go from audience to participating without even realizing it. So that was a moment in there that was very positive. So if you got to make it through these standards and you got to go through this process, stay positive, because that will catch on. So any questions? Yes. Lack of faceplates.
So it's not that custom actually. Like all of these little symbols here, I started with the situational awareness library, and it's like a faceplate really. It's called an embedded symbol or an industrial graphic in Control HMI. So it's kind of the best of both worlds of a symbol and a faceplate in Foxdraw. You could pass parameters in, substitute text, all that stuff like you can with the faceplate. One thing I didn't point out, of course, it went to the screen as soon as we kind of reserved this extra space on our widescreen monitors for overlays to open up. So if you click on a pump or a value or something, it doesn't ever cover up your HMI. And I think that's one of the recommendations from the standard. Again, not a requirement per se. Someone else in the back. John, I'll give you a mic.
The operators accept it and like it and can't wait for you to do it to the rest of the plant, or is it so-so, or?
They're definitely used to it. They're using it on a day-to-day basis. They really have no complaints. Like, are they jumping up and down and asking us to rip through the rest of the plant? No, but Jaron, maybe you can say a little bit better than me, but they're using it and they like it, right? Yeah. They're not missing it. Yeah, they're not missing any information, and
Yeah, and I'll, point out the key thing that I've seen on multiple projects where you're messing with what the operators are used to. Wherever you start, you can't stay there. If you start giving them things they ask for that don't compromise your philosophy, because like I said, they're going to ask for A, B, C, and you say, I can't, instead of saying, I can't do that because A, you figure out a way to give them what they're really asking for, and then you do that a few times and they start really getting buy-in, like they design the screens, not you.
So, and the other question I got is, why situational awareness? I mean, I know about the standard. I know it's been out there a long time, but what do we hope to gain from it?
well, when I came on board, that was one of the things that I was asked is, just look at standards, consider standards, what can we do to improve things? We knew that we were going to have to eventually buy something other than FoxView, Foxdraw. everything just kind of fell in place with what Schneider was offering and the studying of the standards that I did. In my own opinion, in terms of situational awareness, it's based on human performance. And I guess the engineer in me, I bought into that. You know, if this is the way that that you're telling me that it should be, and this is what catches somebody's eye, and there's a philosophy behind the use of colors, I'm okay with the fact that it looks grayscale, because it does look like grayscale to most people. But if you consider where the color is, at least it tells you something. And I bought into that philosophy, so that's kind of how we ended up down that path.
Yeah, the long answer is the standard. I won't quote that to you. The medium answer is a book called Dave, correct me if I'm getting this, the High Performance HMI Handbook, I think. I might have gotten one word wrong there. But it's, you know, it's a thin book. It's a couple-hour read that talks about, you know, the guys that came up with this, they did studies and they did trials with this, all for the purpose of, you know, the name gives it away, situational awareness. You want to be able to quickly understand what's happening with your process. So, you know, that and getting rid of a lot of, I won't call them bad habits, but maybe artifacts of, you know, we when HMIs first went to graphics instead of panel boards, you know, it was like CRT monitors and, oh, this is so cool, we can do a lot of stuff. So in a lot of ways, it's going back to what the panel boards gave you, in that you could look across a panel board, all my lights are in a row, all my analog dials are straight up and down, everything's good. So it's, a lot of it is really inspired by the, you know, that type of quick glance.
Your operators, they had previous FOX-U experience. I mean, they were control operators already that were moving into this area.
Yeah, absolutely. We used the operators from the existing evaporator to help us start the second evaporator.
And then the guys that are running this, are they being exposed to both?
They use both. So the operation of our current situation, or the situation is this: we run the second evaporator when we can. We've sold a little bit of product off of it, but we're still kind of leaning on our first evaporator. When we get a little bit more on an even keel, we'll be bouncing back and forth. But it's those operators that come back and forth. They run both. Absolutely, absolutely. Yep,
that was specifically a concern
Yeah.
throughout the project. That's one of the things that they didn't want to change the graphics, is because now they've got to learn too. And the answer is to make yours so much better than what they have that they don't want to go back.
Yeah.
Well, I don't know that we're 100% there, but I think we've at least given them some stuff that make them happy to deal with whatever.
Yeah. John, there's a question over here in the middle.
I have a good reason why those grayscale graphics are interesting for the plant. And once there was a plant shutdown, and an operator was telling us, yeah, in all those coloring, I couldn't see where the problem was.
Mm-hmm.
And I think that says enough, that it's very important that you only highlight the things which are happening wrong, so that the operator has directly an eye on what he has to do, and not looking for where he has to take some action.
Yep.
Thanks. Yeah, one more time I'll say that the standard doesn't have any hard and fast rules, or it doesn't have many. And the one that gets assumed is that you can't use color, and that's not true. Like in some of your screens, you could see for tank levels, we use like a light blue color. Never does it say that you can't use colors, but if you're using color, it should be representing something they need to know, right? Don't make it red because you buy a certain brand where the motor is red. Make it red because there's something that needs to draw their attention.
If we're over, I apologize. But another thing too is you'll see these buttons here, these arrows for navigation. When you push those, then you go to that next section, and when you land on that next page, it'll leave your little button where you came from highlighted for a moment. I really like the navigation. You guys did a good job on that. That's not something that I've asked for, or I don't think we asked for specifically, but I do like the navigation. There's another
Real
question
quick,
over there.
I don't know the Control HMI product that well, but I know in FoxView there are some hard-coded indications from the control system, like cyan being out of service, red being under range, over range, green, something else. Did y'all have any landmines? Does Control HMI enforce those same colors, and did y'all step on your
Yep.
toe?
So
with
they
any of that?
default to the same colors. Similar, like I talked about element styles in that same configuration, you could change it to not be cyan, you could change it to be something else, but by default they set the defaults to look like FoxView Foxtrot.
I know years ago when I first went through some of this stuff, I went to the local university and I said, hey, I want to learn about this Control HMI, the abnormal situation graphics, not Control HMI, but that stuff. I'd read the book and went to the engineering department at my alma mater, UAH, and they said, you got to go to the psychology department. The guys that do that are over there. And I'm like, yeah, I'm not allowed over there anymore for a lot of
Not
reasons.
allowed out. Not allowed out.
But that's where they
You just
are. I
learn
mean,
too much about yourself
Yeah,
when you go
they still got studies of me going over there. But yeah, it's kind of interesting because it's not really. I mean, this is all an engineering discipline, and we have to implement it. But all of these are human factors studies, and they're all being done by the psychology department, and that's where they do this. And so it's not stuff that the kids are coming out of school with much background in. And there are a lot of books on it, and you can read a lot of stuff, but it's not things that we got exposed to as engineers. So we're having to go back and learn that. And and it's kind of funny. I joked with Don early on. You kept saying you were talking about operators. I said, who are these operators they keep talking about? We'll just tell them what to do. I mean, it's like, but that's not really the way to go. I know that, but anyway.
The old FoxView, the nice one, you say? Yeah.
That's where the plant lives, right? And so when you do this, you have to give all that up.
Too far. Yeah, so
It's a good way to see how it works. It's busy for an operation.
yeah.
Can you tell me what's going on in the screen?
It's busy, and to Dave's point, this is not based on human performance, whereas the high performance.
So
There's a reason why it's
still do end
situational
up
awareness
with-
and high performance graphics. There's a reason why those terms are used. This really doesn't. I'm not saying you don't have the right to like this. A lot of people do love this, but this isn't though. This isn't this. Yeah. Oh yeah, this would be a level 1 screen
No,
if you.
it's not.
No, I'm not saying this is a
not
level 1 screen,
anything.
but like the level 1 screen, the level 1 screen is a depiction of this, but it has areas.
Yeah,
it
this,
has
this
effects.
is level 1 in scope, but
Yeah.
not in detail.
Correct.
So there's just too much information on this to now, like when you get into a level 2 screen, you start drilling in on like this area and what's important about, they call these their blend tanks. So like I'm blending, I'm looking at the blend screen, and they had quad monitors, so they kept usually a bunch of level 2 screens up and maybe the level 1 and then 3 level 2 screens until you need to go do something abnormal. If you're designing it, anytime they're going to a level 3 screen during normal operation, you should think about why they're on that screen. It's, that should be an abnormal situation or some kind of manual intervention. But that level 3, this is the level of detail. Like if you took this and made it bigger, that'd be a level 3 screen. So yeah, and if you make your navigation flags, you can still kind of follow the process through device by device that way. Like if you're trying to figure out why you don't have any flow, you follow that through. That's one of the use cases, one of the functions the operator needs. So
guys, just to comment on that screen there. There's too much color on it. I agree with you as far as the standard's concerned, but you cannot get away from having a process flow because you have to understand that the outside operators will come into the control room trying to learn how the overall process works, and you got to have that. If it's just faceplates, back like it was a long time ago on the panel board, and some of you guys that's got hair as gray as mine probably remember some of that, it was very hard to train operators how to run with just faceplates or a panel board, versus if they could actually see how the process went together, they understood it better. So I think it's wrong to get away from process flows like that. That could easily be cleaned up, and possibly that gets cut into two graphics based on wherever the break could be, based on how you would start and stop it. So you're not having to switch back and forth on graphics or what have you. It's just a comment.
Yep. Understood.
And another comment I'll say, as far as getting operators involved, I think it is very, very important. But if you're putting in a new system with existing operators, you have to teach the operator. First of all, usually just pull one out, or that's where I've been very successful in doing, pulling one operator out that the other operators respect. So you pull that guy out, and then you show him, because they know what they have now. They're experts on it, but they don't know what they could have. Mm-hmm. So if you can show them what they could have and how it could make their life easier, they'll get buy-in, and the rest of the operators will buy in off of that guy. That's where I've been successful.
You mentioned one operator. I want to touch on that. Is like, we definitely had, I think in the early design phases, more than one operator. As many people as you can financially pull in to get ideas from in the back of the napkin phase, because sometimes your best ideas come from your worst operators, because they think different than your best operator. Your best operator is an expert. It's, if you have to explain something to somebody who doesn't understand that well, you get a lot of good ideas in that phase. And then, I will say that, on this project we had, I think I was mentioning to Bob, is like, I want that operator who's as cynical as can be about it, but without completely just like sabotaging it. You don't want the operator that just agrees with everything you say. You want that feedback, even if it's maybe a little demoralizing to have them complain about your graphics all the time. What they're saying is real, and you just got to pick out the parts of that that are useful.
I think. Not sure about in the other facilities, but I'm not the one training the operators where I come from. In your experience, one other thing, we may have a high turnover of operators. So in your experience, what is the experience of, say, a lead operator or whoever's training new operators, as far as one versus the other? Is one onboarding quicker?
So I'll give you two answers. The first answer is from the high performance HMI. That's one of the metrics they use to determine that, hey, we should start doing this. It made very little difference to experienced operators if you went to high performance HMI. They're so good with the graphics they have, they know where to look. They don't have to find the number on the screen. Their eyes go straight there. Where it really brought advantages in the studies they did were training new operators and having them to respond to abnormal situations. So I think I'm still on. In my experience training, I can only give you a part of an answer, because when we install systems, we work with the operators there. We don't stick around and see them train an operator 6 months later. So it's not a lot to add there. I would stick with the textbook answer on that. And that
I would say too, since the beginning, like when we started with, you guys were mentioning like one operator that had that, strong personality or whatever. Somebody comes to mind. We definitely had that. Second thing I want to say is, like they've already trained that person has already trained a couple of people already on this system. So it's like this guy that was the strong personality, a little bit of an opposing view, is now not only using it every day, but has trained a couple of people already. And so that's I'm not saying it's not our responsibility, but that's up to operations. And to me, from my perspective, it looks like they're kind of taking off with it. So I don't see any negatives there. I don't know if that answers your question exactly.
I just want to point out that operator, like, I'm not being sarcastic when I said he was the best person to work on that project, because he was respectful. He never just like started cussing me out because I turned his pump gray. Like, but he was just honest. A lot of people just don't want to give feedback. So you really need that person who's going to tell you what they don't like. And ideally they tell you that, and then they
Okay. I'll take that as a hint.
Do we have time? I'll keep answering questions all day, but okay.
I just do have one question about all this right here, and we talked it earlier in another session about simulated runs. Have y'all run that through a simulator as well, or y'all just running it all live?
We did some basic simulation, like what they were talking about for an FAT, the most basic simulation. We did that for our factory acceptance test, but I'm assuming you guys haven't done this without telling me that there's no like process model for it or anything like that. That's fine. I want to see it.
All right, thank you.
Yeah, thanks, guys.
Trying to, catch up on the time. What's that, David? Okay. Well, first of all, let me tell you real quick. Everything that we've been doing up here obviously came from customers, and I just want to say, we've invested, not EOSYS, but the customers has invested literally thousands of dollars to come up with these tools or tricks or the pain, but they want to share this with everyone else to make sure that we help in some way. And over, we are blessed to be part of y'all who wants to share this knowledge. And talking about tools, so the thing that I have is actually related to sequence logic. So who all in here has sequence logic in their plan? Okay, pretty good number. So who likes to troubleshoot the sequence? Put your hand down, John. So basically, once you get it to work, it works, right? And you kind of set it aside, don't even have to think about it. But when it doesn't, it's really hard to troubleshoot, right? So just real quickly, I'm going to try to make this as quick as possible. So here we have a batching operation. Easy enough. Okay, but now when you say, hey, we've got 5 of the same one, and we want to make sure that if they're all consistent, everything else, we have shared resources, shared destination, blah, 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 it all gets more complicated. Now you throw in the fact that all of a sudden it's all written in HLBL. So that even makes it more complicated. So let's make it real for a second. You hadn't thought about this sequence in months and months, and if it was me, then it, days and days or hours and hours is enough to completely forget this. So now you get a call in the middle of the night. It's 2:30 a.m. Saturday night. You stayed out late the night before. You didn't get in bed until 8 o'clock. So then, hey, the operators, what do they do when they call you? Every one of them is like, everything is broken. We're behind. Everything is backing up. We got to have you here as quickly as possible. One of the quickest and the first thing that comes to your mind is, it's not a DCS problem. If it ran yesterday, it's going to run today. Nothing has changed. Then they tell you, hey, the mill manager is here and he's there to help. In other words, get out of here as quickly as possible, right? So we grab our coffee, we head to the site. So here we go, let's jump in. First stop, everyone does the same thing. Let's run to the select pages. So, you know, prepare to be amazed, mill manager. Oh, crap. So, we're in the wrong AW in front of the mill manager. Hi ho, hi ho. Off to the right station we go to stay in character with Dopey, right? All right, so now we finally get to the right AW. We got the right sequence pulled up, and now we expand it. Hey, everything's looking a lot better, right? All of a sudden, you see, wait a minute, this line, you can't see everything, right? And you see the and not. That means and not everything is shown. So then you look a little further down the page and you see, hey, you know, this, I can read this, I get what it's doing, but it doesn't make any sense to me. So if you have good programming, if you were looking at the actual logic, you would actually see, hey, this line is closing the liquor valve. Down here, we're setting the white liquor accumulator. So this is a preprocessor helping you out. It tries to hide a lot of the stuff from you. So let's go and look at the actual logic. Now, thank you, Foxborough, for putting this little source code here. So yeah, let's jump in. Wait, this can't be right. That's all there is for this sequence when you pull it up. Go to the S file, sure enough, all it is include files. So guess what? You have to find the include files, right? When we finally find the troubleshooting screens or the actual code, all of a sudden you don't have the numbers out here, so you're going to have to figure out where are we in the logic, right? So after this is all said and done, the question is, how do we improve? And if you're like most of us, you build some sort of a troubleshooting screen, right? And in this particular episode of what we did, we actually built a troubleshooting screen, and to kind of fill you in the number of sequences we were dealing with, this is all of the sequence blocks that you're dealing with, and the ones that are inactive are gray and the ones that are active are white, right? So it's not really high performance, but you know, close enough for us who thinks gray is high performance. So let's go a little deeper. So you select one of these buttons and we come to level 2. And the level 2 graphics, you'll actually notice, hey, look, here's all the logic broken down into segments. And not only is it just the logic, it actually has the subroutines and the exception handling and all of the logic as well. So, and that's what I'm actually trying to say here is, hey, all of these correspond to your subroutine and statement number over there, and these are the labels. And oh, by the way, the one that is highlighted is your active steps, right? That's where you're hung up. So let's go a little deeper. Select on one. Now you can actually see the actual code. And with this actual code, this is truly what's running in your logic or in the processor. And I'll get there in a second. Yeah, so no, I actually built it, but it's actually all automated. All of this is automated. So you see the line numbers. Now these line numbers, if you notice in your code, in your S file, they're not there, right? So what we actually had to do is take the R file and then correlate the two together and actually pull this information back. And you see there's a lot of things that you kind of have to deal with. Number one, the preprocessor changes things, so you got to be smart enough to reverse engineer that. And also, you'll also see that there's a couple of lines that don't break right. So you've got to look for those. And then that's how you build your line numbers. Okay, let's go a little further. So the white actually indicates either your constants, or it's also your macros, or an internal variable, which we wouldn't be able to see the actual value. But so the red is actually the false, the green is true. Anything that is an analog value would be blue. And if you also notice the constant in brackets, the macro is defined, what the macro actually represents. So the labels highlighted, right? Easy enough. Cool thing is you can actually read the whole line. It's all there. So this is the one part that I really like. See the value button up on the top? You mash it, all of the values show up. So you right click on any of the values, you see your compound block parameter. So this is a notorious string because if you actually see the very first line, you have if blah, 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 minus blah, 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 greater than. If you've ever tried to troubleshoot sequence as you're running it, by the time you go and look at this value, look at this value, look at this value, and then look at this value, everything's changed again, right? Well, the cool thing is when you have this that you can click on, you can all of a sudden see, unless you're like me and got to pull out a calculator and it takes too long to plug it in, but then you could see if this is true or false, right? Real quickly. So for those like me who cannot think without a printout, we also created text files that actually does the same thing. It pulls together all the include files all in one place, and it puts the logic in there. The cool thing is it actually corresponds with the .r file line numbers. At the very end, the people that are used to the old PLB, it has cross-reference. The ones that has the asterisk beside them, those are destructive sets. So if you're looking through your logic trying to figure things out, then, oh, by the way, cook mode is actually set to something on line 131. Or a couple of other places where there's multiple places where that value is set, they're also shown. All of this is automated. So we actually can have a save all, generate, actually we take the .s and the .r file right out of the save all, and we're able to run through it. Now, we have tried it on some of the other ones, some other customers' .s files, and there are situations right now that break it, but this is something that we've done before, and it's really been very valuable. So here's one of the things. I love the fact that y'all are sharing this information with one another. And what we would really like to know is if y'all have something that y'all want to share that could help somebody else out, let us know. We don't care if we are the ones that's standing up here and doing it or whether y'all do it, just let us know. That's it.
Can I get a share of hands?
Okay, everybody, let me just put a quick concluding remark on everything. Yes, what? Oh yeah, before we do that, and before I claim this laptop, does anybody know whose this is? It's been up here, it's not mine. I don't know, I haven't opened the bag, Galen. Is it yours? You could say, if you say yes, it will be. What? It was upstairs and somebody brought it down here? Well, now they're looking for it in the wrong spot. Yeah, somebody, yeah. Unattended baggage. That's going to be, I'm on my way home. I go by unclaimed baggage in Scottsboro, Alabama. I don't know if y'all know about unclaimed baggage. Yeah, it's like used to back in the day, okay? Unclaimed baggage gets stuff, they have contracts for like airlines and railroads. And if baggage doesn't get claimed, they take it down there and they sell it. Okay? Well, that's fine. And before the internet, today, like everything is kind of priced because if they find something weird, they know what it is, right? But used to, back in the day. Back when I was in college, we would go over there every 4 or 5 months, and you would find stuff that they had no idea what it was. So we had a guy that was a buddy of mine, and he bought and sold stuff from unclaimed baggage all the time because he would know what it was. And he found a high end, and when I say high end, I mean it was like really high level optics and stuff, professional, like scientific microscope, several $1,000 microscope. He's like, oh man, this is this super high end thing. And he bought it for $40 and turned around and sold, and this is when we were in college, man, and sold it for $500. And we were like, we drank on that microscope for I don't know how long. It was great. But they don't do that anymore. Now they find something and they Google it and they're like, oh, it's worth this much, and they price everything kind of appropriately. Well, this is the end. Thank you. Before I let you go, there's a nuclear session after this. Everybody is welcome to attend, but it's the nuke guys talking about nuke stuff, which is fine. It's all IA related, but I won't hijack their thing. We ran long anyway. I would like to thank the Schneider people who helped us out, like Christian for picking up the tab the other night. Andy's over here. Thank God. We had Thad, Frost, and Marcel. They're not on right now. We had Luke Windsor and Vishka, and the last name I won't even attempt to mangle. And then today we had Brian McAllister in here, and we just saw Randy Miller. So thank you guys, the Schneider guys, for doing their thing. Also like to thank the vendor people that showed up. Winston Jinks with Cape Software. I don't know if Winston's still in the room. Winston's over here. And then we have Levin Talman with Talsoft sitting over here with his group. Thank you very much. I appreciate y'all being here. Don Bartusiak, thank you, Don, for coming. I mean, I think it was really nice for you to come and spend some time with us, so I appreciate that. And then I want to also say a special thanks to the customers who got up here and did something, because this is a users group meeting, right? And so we had Rick Targoski over here, and Rick did his thing. We had Joe Scott, who hosted a session. Galen has been moderating and helping out. We had Kevin White do his thing today, and Bob Jones with Galloway. So I feel like we got a good amount of user participation, and I appreciate that. That makes it meaningful for you guys. I think that helps a lot. So, and I hope you all got something you can take away, that this was worth your time, the money, the expense and hassle of getting here. And I hope you enjoyed meeting each other. I encourage you to help each other on the list. Appreciate this so much. And with that, I'm going to let you go. Thank you very much. Maybe I'll see you next year. Thank you very much.